Hi everyone, this is the next lesson in our series about continuous probability density functions. Now, this example here, the length of time in seconds for which a 2-month-old baby smiles is equally likely, that's an important phrase, to between 0 and 18 seconds. And x, our random variable, is the smiling time. Write a probability density function. So let's just consider a little graph here. Our value of x goes from 0 to 18. This is our probability function. It says it's equally likely. It doesn't matter what, where I look, I'm going to get the same value. So it's like this. Now, if it was below that, it would be 0. If it was beyond that, it would be 0. It's literally a nice rectangle. So how will we calculate the value here for this probability function? We'll use the fact that the area has to equal 1. And as that's a width of 18, I think that we can see, without too much effort, that this is 1 over 18. 1 over 18 times 18 gives an area, a total area under here, equals 1, as it must. That's how we figure it out. Now we need to write that function. Well, this is going to be a piecewise function. Our function, let's call it p of x, equals. Now it equals the number 1 over 18 as long as x is between 0 and 18. It is 0 for all other values. So if x is less than 0 or x is more than 18, the probability function is 0. So see the red line here is 0 on the outsides. That's part A. We have written our function. Part B, calculate the probability that a randomly chosen 2-month-old baby smiles between 3 and 15 seconds. So let's have 3 there and 15 there. What we're really after is the area there to answer this question. So the probability that our random variable is between 3 and 15. It's the integral from 3 to 15 of our probability density function. We can do lots of complicated maths, or we could just work out the area of a rectangle. If that's 3 and that's 15, then the width of this little interval here is 12. We know the height is 1 over 18. So although it might be nice to write the integral, it is going to be much, much faster if I go 1 over 18 by 15, take 3. That's 12 over 18, which cancels to 2 over 3. There is approximately a 67% chance that a randomly chosen baby will smile for between 3 and 15 seconds. That's a uniform distribution. If you see the phrase uniform applied, it means this. Chances are all the same, so it's a nice little rectangular one. They're pretty straightforward. And yes, I could have substituted my 1 over 18 into here and done the integration. It really wouldn't have made any difference. I'll get the same answer straight away. Here's another example. These ones are called triangular probability distributions. Now let's do this one. Let's do C. We have to find the probability density function. Start with a diagram. Minimum value is 8. Maximum value is 21. The peak value occurs at 12, so that's around about here. So I'm going to get a function which is 0 to this point. Now the name gives it away. It's a triangular function. So the probability function is shaped like a triangle. And the question again, what's the height of this triangle? This is our probability function, and this is the variable x. Well, we know the area has to equal 1. The base of this triangle, 21 take 8, by the height of the triangle, I'll just label that as h, and area of a triangle, of course, is base times height over 2. What will we get here? Well, 2 times 1 is 2. 21 take 8 is 13. I think h is 2 on 13. What an inconvenient number. So the coordinates of this point are 12, 2 on 13. This point, of course, is 8, 0, and this point is 21, 0. Now, in order to give the probability function, we're going to have to give the equations of straight lines between these points. Now, there's 2 different straight lines to worry about. So here comes our probability density function. Once again, it will be a piecewise function. This first one, what have we got there? If I wanted to find the equation of a straight line running between those 2 points, well, let's go across to the side and do a little bit of working. I would have y minus 0 over x minus 8, I'm going to choose that one, equals, well, what's the gradient? It's 2 on 13 take 0 over 12 take 8. So y take 0 over x take 8. Now 12 take 8 is 4. 2 over 13 divided by 4, that's 2 over 13 by 4. So cancel that, cancel that. That's the same as 1 on 26. So y minus 0 will be 1 on 26 by x minus 8. That's a perfectly good way to write a function because y is the subject. So here we go. What's our function? 1 over 26 by x minus, it was x minus 8, wasn't it? Yes. And what was that condition? Well, if 8, x was between 8 and 12, that's what we would get. Now we better do the next one. For the next one, what are we going to get? Well, we'll go y minus nothing over x minus 21. And what's our gradient? This time it's 0 minus 2 over 13 and 21 minus 12. So y minus nothing over x minus 21. That's going to be negative 2 on 13. Now 21 minus 12 is 9, 1 over 9. That's inconvenient, isn't it? Because that's going to be negative 2 over, now 3 9s are 27, carry a 2, 1's 9 is 9 and 2 is 11. So y would equal negative 2 over 117 by x minus 21. There's the straight line equation for the second part of this. Minus 2 over 117. X minus 21. And this applies when x is between the limits of 12 and 21, and 0 for all other values. There's our piecewise probability density function for this one. That I'm not going to do all of them, that's a good example. And of course we could use this to calculate probabilities if we found areas underneath this triangular shape. Now, would you integrate? You could. Would it be easier to work geometrically with the areas of triangles? Absolutely. And that's what I would do if I had to. That's enough for now. Thanks for watching.